Hello everyone. In this video we look at the uniform speed and velocity motion consideration for the motion in one dimension. Now when we talk about what is an uniform speed or uniform velocity motion, if we consider the journey, then throughout the journey the speed or the velocity is supposed to remain constant. That is what we call as uniform speed motion. If the speed remains constant, if the velocity remains constant, we call it as uniform velocity motion. Now in these uniform speed or uniform velocity motion, one of the important models of questions is this split journey based questions. So what essentially we mean to say by split journey here is if we break the journey into parts, either the division of journey can happen with regard to time, or it can happen with regard to the distance. So we divide the journey into parts, and if in each part, let us say for example here we are talking about dividing the journey into two parts. The division may be in terms of time or it may be in terms of distance. For the first part, it is moving, an object is moving with a constant speed v1, and second part the object is moving with a constant speed v2. Then we will be able to find what is the average speed for the overall journey. Similarly, if we have the first part of motion having a constant velocity v1, and of course here we are going to deal with them as a vector, and second part of the journey with a constant velocity v2, then we will be able to find what is the average velocity of the entire journey. So we look at how we'll go about doing these kind of questions in the next few minutes. If you look at the splitting of the journey in terms of time, let us start with very basic example of the journey being split into two equal halves. Say for example, the first half of the time the object is moving with a speed v1, and second half of the time the object is moving with the speed v2. The thing is, we need to find what is the average speed for the entire journey. Now since we are talking about the time, we do not know what is the total time of the journey, but what we know is the total journey time is divided into two halves. So let us say that the total journey time is t, and we know very well that this t should not be coming in the final expression, because this is a variable that we are introducing. So if we say first half of the time, it will mean t by 2, second half of the time would mean t by 2. Now the average speed formula will be total distance by the total time taken. So total time taken, as we already introduced the variable, it will be t, but total distance is nothing but the distance covered in the first half plus the distance covered in the second half. Now for the first half of the time, which is t by 2, the object is moving with a constant speed v1. So the distance covered in this particular interval will be v1 into the t by 2. Now for the second half of the time, it is moving with a constant speed v2. So the distance covered over here will be v2 into t by 2. If you want to look at what is the total distance for the entire journey, it will be v1 into t by 2 plus v2 into t by 2. As we can see, t by 2 can be taken out common in the numerator, so we will be having v1 plus v2. In the denominator there is already a t, we can see the t will be cancelled, so the final expression will be v1 plus v2 by 2. This will be the average speed for the entire journey. So in some other case, what might happen is the division of journey may not be exactly into two halves. It may be into 1/3 and then 2/3, or 1/4 and then 3/4, or maybe 1/5 and then 4/5, or even the journey can be divided into multiple intervals. Maybe we can divide the journey into 3 intervals of time, 4 intervals of time. But in all this, the approach will remain the same. We will start with the total journey to be some value t, and the individual intervals will be expressed in terms of this t, as in this case since we said it is two equal halves, t by 2, t by 2. In some other case it might change. So we'll be able to find what is the distance traveled in each of these intervals, and we'll go for the average speed formula, which is total distance by the total time taken. So we'll try to look at how do we go about using this kind of an approach through an illustration. Let us say, for example, we have a person who is covering first 1/4 of time with a speed 40 meter per second, and the rest of the time with a speed 80 meter per second. So we need to find what is the average speed for the entire journey. So if you say first 1/4 of the time, the remaining part will be 3/4. Now, as we already discussed in the approach towards solving these kind of problems, we'll start with an assumption that the total journey time, let it be t. So first 1/4 of the time would mean t by 4, and the remaining time will be 3 into t by 4. So we need to find what is the average speed. Average speed will be total distance traveled in the entire journey by the total time taken. Total distance traveled will be nothing but distance traveled in the first interval of time plus distance traveled in the second interval of time. First interval of time, the speed is 40 meter per second. So here the distance traveled will be 40 into t by 4. In the second interval, the speed is 80 meter per second. So the distance traveled here will be 80 into 3t by 4. So we are basically using the idea that distance is equal to speed into time. Now the total distance will be nothing but the addition of both these, which means 40 into t by 4 plus 80 into 3t by 4 divided by total time will be t. Now maybe what we can do is 4 ones are 4 tenths, 4 ones are 4 20s. So what we see in the numerator is 10t plus 60t. So numerator is 70t. So the average speed value, if we take along with the unit, it is going to be 70 meter per second. For the first 1/4 of the time, it is traveling with a speed 40 meter per second, and the rest of the journey, which is 3 by 4th of the time, it is traveling with a speed 80 meter per second. If this is the motion that we have, then the average speed for the entire journey is coming as 70 meter per second. Now let us go and take a look at the approach that we'll have for the problems where the split journey is in terms of the distance. Let us say, for example, the journey is divided into again 2 equal halves, but now first half and the second half, but now the division is not in terms of the time, but it is in terms of the distance traveled. So let us say for the first half of the distance, the particle is traveling with a speed v1, and next half of the distance it is traveling with a speed v2. So we need to find what is the average speed value. So like the way we have assumed in the case of the split journey with regard to time, here what we will be assuming is the journey distance. So total journey distance, because the splitting is in terms of distance, so we say the total journey distance be s, and we know the final expression for the average speed should not have this variable that we are introducing. So if s is the total journey distance, then first half of the distance would mean s by 2, second half of the distance would mean s by 2. So average speed formula is nothing but total distance by the total time taken. So here distance, as we already introduced the variable, it is s. Now the time taken will be time taken for the first interval plus time taken for the second interval. For the first interval, we know the distance, we know the speed, we need to find the time. So time taken for the first interval, so we will use the formula, since speed is equal to distance by time, time will be equal to distance by speed. So s by 2 divided by v1, which is equal to s by 2v1. Time for the second interval will be s by 2 divided by v2, which is s by 2v2. Now total time would mean the addition of both of them, s by 2v1 plus s by 2v2. Now if you take s by 2 common from the denominator, s by 2 will come out common. What we will be having is 1 by v1 plus 1 by v2 will remain. So maybe we can cancel the s and 2 will go to the numerator. So what we'll essentially have now is v average is equal to 2 divided by 1 by v1 plus 1 by v2. We can further take an LCM in the denominator. So take an LCM, it will be v2 plus v1 divided by v1 v2 will come. This will go to the numerator. So thereby finally what we have is 2v1 v2 by v1 plus v2. So this is the average speed if the journey is split into two equal halves in terms of distance. Now even if the journey is split in a different manner with regard to the distance, the approach is going to remain the same. So we'll start with the total journey distance variable as s or x, whatever the value we take, and based upon that the respective interval distance values will be expressed, and we'll use the formula average speed is equal to total distance by the time taken. So time taken for each of these intervals we will use time is equal to distance by speed formula and get the time values and then substitute in the final expression. So this is the approach that we will be taking to solve these kind of questions. Now what we'll do is we'll try and take a look at a different model of question in the split journey with regard to distance and see how we can apply this idea. Let us say for example we have a person covering first 1/3 of the distance with a speed 30 meters per second, and the rest would mean 2/3 of the distance with a speed 50 meters per second. We need to find what is the average speed of the entire journey. So here we have been saying, first we'll consider that the total journey distance, let it be some variable s, and we know that the final average speed formula should not be having this s because s is a variable that we introduced. Now the journey is divided into two parts. First 1/3 of the distance would mean s by 3 and the remaining distance will mean 2s by 3. First 1/3 of the distance, the speed given to us is 30 meters per second, and the rest of the distance, the speed given is 50 meters per second. So we'll find what is the time for the first interval. Time will be equal to distance by speed, which will be equal to s by 90. T2, time for the second interval, will be 2s by 3 divided by 50, which will be 2s by 150. Now we have both the time values for the two intervals. Now we can go for the average speed formula. So average speed formula will be total distance by the total time taken. So which will mean total distance will be s, that is a variable we introduced, and total time taken will be s by 90 plus 2s by 150. What we can do is we can probably take an s common out in the denominator. So we have 1 by 90 plus 2 by 150. So s and s will be cancelled. So what we have is average speed is equal to, if we take an LCM in the denominator, the LCM for 90 and 150 will be 450. So what we'll be having is 455 plus 6 will come. So totally this 5 plus 6 is going to be 11, and the 450 will go to the numerator. So 450 by 11. The unit is going to be meter per second. If you want, we can express the value in decimal places as well, but this will be the average speed for the entire journey. So this is how we know we'll go about solving the split journey problems, and in case of the uniform speed or uniform velocity motion, this split journey problems are one of the important examples.